Hello, welcome to Learn Mathematics. In this video, I am going to solve a question from linear algebra. This question is from CSIR UGC net. CSIR UGC net, June 2011. The question is find the dimension of the vector space of all symmetric matrices of order n by n, where n is always greater than or equals to 0 with real entries and trace equals to 0. And the four options are given here. But what is the vector space? It is given that if we call it as V, then V is the set of all matrices A such that A transpose equals to A and A equals to trace A equals to 0. Now how can we find the dimension of this vector space? To find the dimension of the vector space, we have to we have to take an arbitrary element from V, and we have to show the number of linearly independent element of that vector space we need, which can generate that arbitrary element of that vector space. That is, if we can take two vector, we can take an arbitrary vector A belongs to V, and we can write A as a C1 A1 plus C2 A2 plus dot 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 Cm Am, where A1 A2 dot 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 Am are linearly independent, and then we can say that dimension of V is equals to M. Note that here A is arbitrary. So how can we find this for a general vector space, for a general n? This is quite difficult, but if we consider a special case, so it is easy. So here it is given that n is here it is given that n is greater or equals to 2. So we can consider that n is equals to 2 for a special case. When n is equals to 2, then V is all V2 is we are saying that this is V2 for n equals to 2. All A such that A transpose equals to A and trace A equals to 0. Now take an arbitrary element from this. A belongs to V2. Then how can we write A? A is A11, A12, A21, A22. This is an arbitrary element of V2. Now it is given that A transpose equals to A. A transpose is equals to A. That means that A21 and A12 are same. They are equal. In that case, we can replace A21 with A12. It is also given that trace A equals to 0. What is trace of a matrix? Trace of a matrix is the summation of the diagonal element. So in this case, we can write A11 plus A22 equals to 0. So that implies A11 equals to A22 equals to minus A11. So we can replace A22 by A minus A11 into the first matrix. So in that case, we can have A11, A12, A12 minus A11. This is this is our matrix. This is a general element of the vector space V. Now how can we generate this? If we take A11 outside, then this can be written as 1 0 0 0 plus this is 1, this is minus 1, and A12, then this is 0 1 1 0. Note that this is actually the general matrix. So the general matrix can be written as some real number into 1 0 0 minus 1 matrix plus some real number into 0 1 1 0 matrix. And note that these two matrix, clearly these two matrix are linearly independent. Why? You can check if you take a if you take this is equals to 0, this is equals to 0, then clearly this term, this matrix is equals to 0, this is equals to 0 matrix, then this matrix is equals to 0. That imply A11 equals to 0 and A12 equals to 0. So this is these two matrices are linearly independent. So in that case we can say that that we need two non-zero elements of V2 to generate an arbitrary element of V2. So we can say dimension of V2 equals to 2. This is true. Now now what we have that in the first case, first option is what is our first option? N square minus n by 2 minus 1. This is our first option. If we consider this first option, n square minus n by 2 minus 1, substitute n equals to 2 because we have for this special case we have considered that n is equals to 2. For n equals to 2 we have seen that dimension of the vector space is 2. So in each option we will find the dimension of the vector space by substituting the value of n. So we have 2 square minus 2 by 2 minus 1, and this simplifies to 0. So option 1 is incorrect. Now look at option 2. Option 2 is n square plus n by 2 minus 1 equals to this 2 square plus 2 by 2 minus 1, and this simplifies to 2. So option 2 may be a correct option, but we can't say this is correct option because we have considered a special case. In for n equals to 2, dimension of V is 2, and we can see that in option 2 we calculate for n equals to 2, then we get 2, but we can't say this is the dimension of the vector space. This is the correct option because we have considered the special case. Now let's check option 3. For option 3 it is n square minus 2n by 2 minus 1. So we have n square minus 2n by 2 minus 1. So in that case we have 2 square minus 2 into 2 by 2 minus 1, which is simplifies to minus 1 and minus 1 cannot be a dimension of any vector space. So option 3 is incorrect. Now option 4. So option 4, for option 4 we have n square plus 2n by 2 minus 1. So in that case we have 2 square plus 2 into 2 by 2 minus 1. So we have 2 square 4 and 4 8 divided by 2 is 4 minus 1. So we have 3. So this is also not a correct option before n equals to 2. So we have seen that option 1, 3 and 4 are not correct option, but 2 may be a correct option. So this must be correct option, otherwise the question is wrong.